Okay, this is sequences series day 5, infinite series, and ratio test. I'm gonna go off the grid here a little bit, and I'm gonna make my own page. So I just want you to observe, and then we can transcribe this later if you want to. I want to talk about I work well with flowcharts. You may too. It makes sense to me to be able to answer a question yes or no, and then go a different track. So if said thing doesn't happen, now I know I go this way. All right, so I'm going to set up for you a nice little um, flow chart, which I've written down so I don't forget anything. Okay, so let's talk about series. Let's talk about series. And our goal overall in this chapter is to do one of two things, to determine does a series diverge or does it converge, right? Is the area under that curve, is it finite or is it infinite and going to go on forever? So that's our overall goal, right? We want to figure out, does it diverge or does it converge? All right, so we're going to have a nice little flow chart of where do you start, how do you know where to go, and whatever. So let's take a sequence, a sub n. The first thing we want to do with any sequence is take the limit as n goes to infinity. All right, if that sequence equals a finite number other than zero, not equal to zero, you are done. That is a divergent series. It is a divergent series. So if the limit of the sequence does not approach zero, it's divergent. So if I took 10 and multiplied it by 2, I'd get 20, then 40, then 80, then 160, and so on. If I was to add up all the terms of that sequence and make it a series, of course it's going to diverge. Right? Well, what if everything approached, like our term approached a value of 1/2? Well, toward my last term, I'd be just 1/2 plus 1/2 plus 1/2 forever will also be an infinite series. I want for my last term to approach 0. Okay, we talked about that. So if the limit as the sequence goes to infinity is some number other than 0, then we say it's divergent and the process is done. Okay, so how often does that happen? Yeah, not that often. Sometimes, but not that often. Now, let's say it equals 0. Well, then it could be a candidate for convergence. Okay, before I told you if the sequence converged to 0, then it was convergent. Then the series would be convergent. But it's not always. It's not always. An example of when it's not always would be 1 over x or 1 over n, right? 1 over n as n goes to infinity would be 0. However, we found last chapter that the integral of 1 over x dx from 1 to infinity, what happened to that? It diverged, right? The area under the curve. So just because the limit of the sequence is 0 doesn't mean that it does converge. It just means it might converge. So that's where my little caveat disclaimer would be. So this means it's possible that it converges. It being the series. So we have a number of tests that we can do on the sequence, and today's test is the first test that you'll have. It's called the ratio test. Okay, so our first possible option of what to do would be, okay, well, let's use the ratio test. Now, there's 3 outcomes of the ratio test. Okay, and I'll show you how to do the ratio test in a moment, but if the ratio test comes out to be less than 1, right, we're going to take each term, or the n plus 1 term divided by n. If the limit as n goes to infinity of that is less than 1, the series converges. If the limit of that ratio of the n plus 1 term over the nth term is greater than 1, what do you think is going to happen? Divergent. So at this point, we'd be done. And if the ratio test shows us that the limit as n goes to infinity of the n plus 1 term over the nth term equals 1, we don't know. It's inconclusive. Inconclusive. So go figure. It's like a sequel, right? Well, if the limit of that ratio is greater than 1, it's going to be divergent. If the limit is less than 1, thank you, I'm done. Either way, I'd be finished with the process here or here. But if it's equal to 1, that means there's going to be more tests to do to this thing, to this sequence. Does that make sense so far? Okay. All right. I think that's good for the flowchart. This flowchart will continue, right, from inconclusive later. Okay, so let's take an example here. Show that the series, right, n squared over 5n squared plus 4 diverges. Well, this is how you'd write the series. I could write the sequence like this, right? The sequence is just the term or the expression in terms of n. The series would have the summation notation and all that stuff to go along with it. So as you look at that and you send n to infinity, right? Some of you recognize that you can just take coefficient 1 and 5 and divide them, you get 1/5. If you wanted to algebraically, you could divide everything by n squared. That would make the numerator 1. That would make 5n squared equal to 5. And 4 would become 4 over n squared. And you could see as n goes to infinity that you would clearly get 1 over 5. Okay, is that value equal to 0? No, so we know it's divergent. What's divergent? The series. The sequence is convergent, right? It converges to 1/5. The series is divergent because we're going to be adding 1/5 forever. All right, so here a little bit more proof. This is going to be the ratio test, okay? So I'm going to take the limit as n goes to infinity of the ratio of the n plus 1 term over the nth term. And let's just do an example because I think that's the best way to see it. I don't really like that. Let's do one of the homework problems. How about that? Sound good? I like it. Okay, so first of all, let's say this. Are these examples? Oh, these are examples. These aren't homework. Examples. I think E is pretty yucky. Do you guys agree? Yeah, pretty yucky. Let's look at it. Let me just first go through the flowchart here. Let's take n and send it to infinity of the sequence itself. 2n plus 1 over 2n minus 1 times 1 over 3 to the n minus 1. Would you agree with me that as we go to infinity, these would go to 1, right? 2n over 2n would go to 1, and then this obviously would go to 0. So this would go to 1 times 0, which would equal 0. So we know the sequence converges, but we're not quite sure if the series converges yet. So on the flowchart, we've said yes, it equals 0. Now we have to test the ratio test. So what I'm going to do is I'm going to take a sub n plus 1 and divide it by a sub n. Well, and the absolute value of that, it's kind of not needed, but formally we use it. Okay, so let's write out what a sub n plus 1 would be. Well, that would be 2 times the quantity n plus 1 over 2 times the quantity n plus 1 minus 1 times 1 over the quantity. How could I write this? If I add 1 to that, what would it be? N minus 1 plus 1, which would just be 3 to the n, right? So that's the n plus 1 term. That's the n plus 1 term. And we're going to divide that by the nth term, which is just what it is. Now, instead of dividing, you guys, I don't like to divide. I like to multiply by the reciprocal, which is what you should do too. So if I multiply by the reciprocal, I would get I would get 3 to the n minus 1 over 1 times the reciprocal of that. So I'd have 2n minus 1 over 2n plus 1. All right, let's clean this thing up. I'm going to pause the video because I feel like I might run out of time. I'll clean it up, and you kids on the web, it'll just be there. That's right, I'm verified. I gave them my banking routing information and social security number, so they said I could go over. That was a great idea. Yeah, I know. Okay, let's clean this up. What would this be? 2n plus 3. What would this be? 2n plus 1. How about that? 2n plus 1. Okay. I'm going to multiply that. I'm just going to bring this 1 over, I'm going to put 3 to the n right there. Let's continue. How could I rewrite? What do I want to do here? Okay. 3 to the n minus 1 times 2n minus 1 over 2n plus 1. Right? Can I cancel anything? Yeah, I can, right? What can I cancel? What is 3n equal to? 3 to the n minus 1 plus 1, right? So I could really write that as 3 to the n minus 1 times 3 to the 1. You with me? Because what do I do with these two things? I add them, right? That's just 3 to the n, right? If I add n minus 1 plus 1, I get n. So this is technically, like 3 to the n is that, and I see a 3 to the n minus 1. So that'll cancel this and cancel the n and just make it a 3. Let's go. Okay, so as I clean this up, I get 2n plus 3 times 2n minus 1 over 3 times 2n plus 1 times 2n plus 1. Watch what I do here, and it might just like this bell in your head might go off and you might go, oh, that's why we had been doing that. Yeah, thank you. That's why we keep you guys around, so that you can watch my mistakes. That should be a 12. I take the limit as n goes to infinity here. Is this going to come out to be convergent series? Yeah, it's 4/12ths, right? So the limit would be 4/12ths. We could call that 1/3. And because 1/3 is less than 1 by the ratio test, a sub n, excuse me, this series will be convergent. All right, so one more caveat. I think that one really solid example like this is good for now, and I don't think we're going to do much more. We might just do some group practice with homework problems. But there's one more requirement for the ratio test. And to be honest with you, at this point, I'm not sure why it's a requirement. So I'm going to try to get answers, and then I'll get back to you, okay? but the requirement is that all terms of the sequence are positive. Okay, so let me go back to the flow chart here for a second. I forgot to do that originally. Eventually. There we go. In order to use the ratio tests, there is a disclaimer. All terms are positive. Okay, and if all terms, like if there's an alternating sequence where you got a positive and a negative and a positive and a negative, we're going to get to the alternating test next chapter. So there is another like layer of discretion involved, right? Not only would the limit of the sequence have to be 0 to be a candidate for ratio test, but all terms have to be positive.